Hi everybody, my name is Ishki Arisa binti Zahrain. So did you guys know that one of the most powerful ingredients in skincare and medicines come from nature? Well, meet salicylic acid, a compound with a rich history and a wide range of benefits. This chemical compound originally derived from the bark of a willow tree, a natural remedy used for centuries to relieve pains and reduce fever. Over time, scientists already uncovered its incredible potential, and today is one of the key ingredients in medicines and skincare. Salicylic acid, in Ayurvedic terms known as 2-hydroxybenzoic acid. The structures features two functional groups, which is hydroxy group that present on the benzene rings, which gives the compounds its phenolic properties. And the second one is a carboxylic acid group, which contributing to the acidic natures of salicylic acid. In skincare, salicylic acid have the ability to exfoliate, unclog pores, and combat acne. It penetrates deeply to remove dead skin cells, making our skin become more clear and healthier. Moreover, in pharmacy industry, salicylic acid is the precursor to aspirin, which commonly used as a pain reliever. Its antimicrobial properties also make it a valuable preservative in food.
The physical and chemical properties for the salicylic acid. Let's start with the physical properties first. So the molecular formula for the salicylic acid is C7H6O3 and the Ayurvedic name is 2-hydroxybenzoic acid. Salicylic acid is colorless, odorless and look like a needle-shaped crystal. As for the boiling point, it is around 200 Celsius and the melting point of 158 to 161 Celsius. The salicylic acid molecule has 2 hydrogen bond donors and 3 hydrogen bond acceptors. Next, the solubility of this compound. It is lightly soluble in water, or we can also say it is poor solubility in water due to its lipophilic nature, but it is soluble in ethanol. Then, as for the density, it is 1.44 gram per cm squared. Its pKa value is 2.97, which makes it to be a weaker acid. Lastly, it is considered to be moderately polar due to the hydroxyl and carboxyl group. Next is the chemical properties for the salicylic acid. The first one is a reaction with base. So we can see here salicylic acid react with bases like NaOH to form salt. So sodium salicylic, the salt form, is more water soluble than salicylic acid. Next is the esterification. The hydroxyl groups in alcohol can react with carboxylic acid groups of salicylic acid to form ester. Like the example shown below, reaction with acetic anhydride will produce acetyl salicylic acid, aspirin. The third one is decarboxylation. So when heated to high temperatures, which is usually around 200 Celsius, salicylic acid will undergo decarboxylation and releasing carbon dioxide to form phenol. Lastly is reaction with acyl halides. As we can see the example below, the salicylic acid reacts with acyl halide like acetyl chloride to form ester.
The next part is the benefits of salicylic acid. The first one is exfoliation. Salicylic acid is a beta-hydroxy acid known as BHA, which is a powerful exfoliant. Its ability to penetrate pores and remove dead skin cells makes it an excellent agent for promoting smoother and healthier skin. Next, acne treatment. This compound is particularly effective in treating acne. It unclogs pores, reduces inflammation, and prevents new breakouts, making it a key ingredient in many acne treatments. Third, anti-inflammatory properties. Salicylic acid also helps prevent redness and swelling with skin conditions such as acne, psoriasis, and dermatitis. Other than that, keratin breakdown. Another significant benefit is its ability to dissolve keratin plaques in hair follicles. This action helps manage blackhead, whitehead, and even conditions like warts and corns. Lastly, scalp health. Salicylic acid promotes scalp health by managing dandruff and conditions like seborrheic dermatitis, effectively reducing flakiness and scale. Now, moving on to the uses of salicylic acid. Firstly, in medical application, salicylic acid is widely used in medical products. For example, it is an active ingredient in over-the-counter and prescription treatment for acne, warts, and psoriasis. Additionally, it is a precursor in the synthesis of acetylsalicylic acid, commonly known as aspirin, which is used as a pain reliever and anti-inflammatory and fever reducer. Next, in the cosmetic industry, salicylic acid is a key ingredient in facial cleanser, serums, and masks. Its pore clearing and exfoliating properties make it popular for treating and preventing skin issues. It is also used in anti-aging products to rejuvenate the skin. Other than medicine and skincare, salicylic acid also used in industrial field serve as intermediate producing dyes and fragrance. It also contributes to the synthesis of other pharmaceuticals such as methyl salicylate, commonly known as wintergreen oil. Besides that, in agriculture, salicylic acid is included in formulation to manage plant disease. It is also known to enhance plant immunity against various pathogens. Lastly, in hair care products, salicylic acid is included in to treat dandruff and make scalp build up effectively.
Next is chemical reaction, where preparation of the salicylic acids. The Kolbe-Schmitt reaction is a well-known reaction is used to synthesize phenol into salicylic acid. In this reaction, carbon dioxide and sodium phenolsides are carboxylated at high temperature and pressure, and then the reaction is acidified. So in the Kolbe-Schmitt reaction, there are three types of chemical reactions, which is the first one is the preparation of the sodium phenolsides through the neutralizations, which is phenol is react with sodium hydroxide and produce sodium phenolsides and water. Next is carboxylations, which is the sodium phenolsides is react with carbon dioxide and produce sodium salicylate.
The Kolbe-Schmitt reaction begins with sodium salicylate, which is subjected to an acidification process using sulfuric acid. This reaction leads to the formation of salicylic acid and sodium sulfate as a byproduct. The balanced chemical equation for this reaction is two molecules of sodium salicylate react with sulfuric acid to form two molecules of salicylic acid along with sodium sulfate. The structure shows that salicylic acid has a hydroxyl group and carboxylic acid group attached to a benzene.
In conclusion, salicylic acid is a versatile and widely used chemical compound. It is useful for therapeutic properties in skincare and medicines. As a beta-hydroxy acid, this unique structure allows it to penetrate oily layers of the skin, making it highly effective for skincare and acne treatments. Beyond skincare, it is anti-inflammatory and exfoliating properties highlights its versatility in medicines and cosmetics. Overall, salicylic acid remains as a valuable tool in medicines and cosmetic application, contributing to enhanced skin health and well-being.